This lesson for grade 11s is working out finite differences. This topic was originally covered in grade 9. Most of you have forgotten. It is used to take x and y data, the table of values, and convert it into an equation, whether it be linear, quadratic, cubic, quartic, or quintic. I have given the data. Doesn't necessarily match this one. In order to work this out, you will subtract in the y value, in the range, you will subtract the number above this one from it. There is no number above negative 76, so we scratch that box out. Then we go negative 25 minus a negative 76, 51. Negative 6 minus a negative 25 is 19. Negative 1 minus a negative 6 is 5. 8 minus a negative 1, 9. 39 minus 8, 31. And 110 minus 39 is 71, I hope. This is the first difference. They're not the same, therefore this is not linear. A linear equation did not make this data. We now go to the second column. There is no number above 51, so we strike out these two boxes. 19 minus 51 will be negative 32. 5 minus 19, negative 14. 9 minus 5 is 4. 31 minus 9 is 22. 71 minus 31 is 46. These are the second difference. They are not the same, so not an x squared. In working out these differences, it's probably better to use a calculator. Third difference, same thing. Scratch out the top three boxes. 14 minus a negative 14, minus a negative 32 is 18. 4 minus a negative 14 is 18. 22 minus 4 is 18. 46 minus 22 is 18. These are the same, so this must have come from a cubic equation. Y equals ax cubed plus bx squared plus cx plus d. Our challenge is to figure out what a, b, c, and d are. This is actually quite difficult, and we'll do it at another time. We're going to look for patterns. We'll start with linear. These are three linear equations. I have listed data down the side, x values, negative 2, negative 1, 0, 1. In order for this to work, the data has to be even. There can't be jumps in it. They can be spaced, but it must be even. We'll get that later. If you fill it in, plug negative 2 into this, and we'll get negative 8, negative 3, negative 2, negative 1, or positive 1, I should say, and 6, 4, I believe. Make a table. We're going to do first difference. Scratch the first box out. Negative 3 minus 8. This, I think, not supposed to be. This should have been jing jing 5, not negative. Okay. It's the careless mistakes. Negative 5 minus is 3. This minus is 3, 3, 3. These are all the same. It must have come from a linear equation. Y equals ax squared plus b. Very often in these tables, you are given the y-intercept. It's part of the table. Therefore, we know b. Y equals ax squared plus, negative 2. Pay attention here, pay attention. Pick another set of values. This one, this one, this one, or this one. It doesn't matter. But you can't use this one. You've already used it. So I'm going to pick 1, 1. 1 equals A minus 2. Bring the 2 across. A is 3. Y equals 3x minus 2. This is the equation that generated that data. Not surprising. We're just proving it. If we do the next one, this is going to become 5, 4, 3, 2, 1. Make a table. First difference, scratch the first box out. 4 minus 5 is negative 1. Negative 1, negative 1, negative 1. Therefore, it is linear. Y equals ax squared plus b. Use the data if possible. Y equals ax squared plus 3. Pick another set of data. I'll pick 1, 2. 2 equals a plus 3. Bring the 3 across. A is negative 1. Y equals negative x plus 3. Surprise, surprise. The next one, more difficult. If I plug negative 2 into here, I'll get negative 2m plus b. Negative 1m plus b. b. m plus b. 2m plus b. Give yourself some room here. It's just tedious. First difference. Negative 2, whoops. I can't do the first box, so scratch that out. Negative m plus b minus negative 2m plus b. If you look at it, b minus b, they will cancel. This will become a positive 2m. Minus m is m. Here we have b minus negative m plus b. This b cancels this b, and that becomes a positive m. M plus b minus b, the b's cancel, leaving m. 2m plus b minus m plus b, lo and behold, m. Y equals ax plus b. That stays. Pick this one, 1 comma m plus b. M plus b equals a plus b. This b cancels this b. A equals m. Y equals mx plus b. That's what we expect. They were all generated by linear equations. They're all going to produce linear equations. If we flip it over, here is an example. We don't know if this data was produced by a linear, quadratic, or cubic. We work out the differences. Scratch the first one. 1 minus a negative 1 is 2. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus is 2. Linear. We don't need this. We now know y equals ax plus b. Using the data, this won't always be the case, but it is kind of handy. We get this. Pick another set of data at 1, 5. 5 equals A times 1 plus 3. You should realize you could pick any set of data except the one you've already used. 2 equals A. That means this guy was y equals 2x plus 3. That was the equation that made that data. This is the end of lesson 1.